Sales Director for Western Europe.
Yes.
And
okay, we'll try to do it quick because the delay is impacting. I have a co-host together with me today. We mentioned earlier during the talks that the challenges of AI are several. It's not only hardware related, but also on energy consumption, infrastructure, and the management. So what you do with the hardware you buy and how to exploit it. And so we will randomly pick a few of the slides of my presentation because I have here together with me Dr. Peter, that is actually maybe you can introduce yourself directly. He is leading our sister company that is helping ASUS to offer market a complete turnkey solution. So he will go through those slides. You can select maybe the ones you want. If this goes
no, you have to look, go from the start, luci dall'inizio, and then it should work. A sinistra. Sinistra.
Okay. That's yours.
No, this is.
They are all together.
No, they are separate files.
That's the one behind.
No, you're right.
So we are going, maybe you can choose the slides you want, and then we'll pick up. You're not getting away with it. We're going through every single slide. But I'm going to let the technical part to Peter.
Okay, thank you. Hello, everybody. My name is Peter from Taiwan, and I'm in charge of AI cluster related business of ASUS. So I'm going to share you that you may know that ASUS is doing good with this computer product. And ASUS is also doing good right now for AI servers, but you may not know that ASUS already invested in 1,000 engineers in AI and the cloud-related software, and we are providing more valuable solution to customers or partners like you to provide really good AI solutions. And the background of our team is that we are coming from Taiwan's National Supercomputing Center, and we are the team to build the supercomputer in Taiwan from 2018, and we are building from Taiwan 2, 3, 4, 5, several kinds of GPU-based or CPU-based cluster. So we are a team who really know about cluster, and we do know the workload that running on top of the cluster. And we are accumulating hundreds of use cases that are coming from, from image AI to language model AI or to genomic sequencing. So we learn a lot from our customers. So ASUS right now is a very good partner to help you to develop proposals to your customer. That AI really is so new, and the customer are asking questions from technologists to businesses to operations. So ASUS right now is a very one-stop shopping partners who can help you to answer those questions right now. So this is our history. And besides the software part, we are also a team who can provide a green data center experience. So you can see that we have several kinds of experience to do low PUE, from pure CPU-based cluster to GPU-based clusters. And this is a very interesting example that the CPU-based cluster we built for Taiwan government is the first Grace chip supercomputer from NVIDIA that is an ARM-based supercomputer. So it's just go live early this year. And this supercomputer not only is an ARM-based supercomputer, but it's a very low PUE, the 1.17. And we are a team who knows cluster. That means we know more about orchestrators or all kinds of GPU or CPU management software. So we can help you or your customer to manage several kinds of different generations of GPU or different architecture of the GPU, and we can help you to deal with different workload, different types of GPU resources. So it's our experience that a customer may ask if he want to invest in GPU, and we are accumulating experience that can help customers to deal with not only the GPUs, but also the networking or the storage selections from all vendors, just like Nest on the past presentation. And we also have experience in deal with IBM GPFS or WCAG or other kinds of self-based or other kinds of storage services. So, and we do have many kinds of use case experience. Not only for a language model, in ASUS we train our own models and we sell the model in Taiwan. So we know what is the problem or what is the technology barriers that a customer may face when he wants to develop their own language model. We are not just selling server. We can help a customer design the cluster, and then we can even answer the question if the customer wants to develop their own model. So we can provide several kinds of value for you. And now we can also provide you some healthcare-related use cases or smart city-related use cases. Right now, we already accumulate over 500 use cases in different verticals. So just ask us if your customer wants to develop something from AI, we can share with you.
They can also run their own system on our GPUs, leverage their architecture, and test their environment.
Yes, thank you for the question. Because we are running our own cluster in Taiwan, so all the use cases we develop can be run on top of our own cluster. It's just like a cluster, so you can just see the demo or check the use case on your own. And for the generative AI, in ASUS, we are not just building our own foundation model. We provide a whole stack that help our customer to fine-tune the model, to deploy the model, or even to use the model. We have a total solution just like an AI portal or the rack solution just like the last presented. So just as ASUS, that we can help you to demo the whole system for your customer. And this part is that not only for the GPU resource management, it's the most important thing for a GPU cluster. We can help you or your cluster to build the cluster use case. To build the workload for different customer or for different department inside your enterprise's use cases. So we can also provide a building support system solutions for you. And that's the last one. Because we are a very experienced team, we already deploy such kind of cluster for over 15 clusters in Taiwan. So we have confidence that we can help you or your customer to deploy such kind of cluster in 8 weeks. So your customer will feel comfortable because GPU is so expensive. So sooner the cluster go online, the ROI will be better.
We have heard in the morning session some end users still trying to kick off their environment after 1 year or more.
Yeah, we actually, in our experience in Taiwan, we developed a cluster in 2018, and the system can go live in a very steady uptime after 2 years. You know, that's lots of engineering work. So please do not waste the time with your customer. Just leverage ASUS engineering resources so we can provide you with very, very short.
So what is the saving between 2 years and 8 years?
Yeah, you can just calculate. Yeah, it's a lot. It's a lot.
So how much is Microsoft?
Yeah. Okay, so I'm sorry, it's one more thing. It's for the cluster.
Take your time. Don't worry.
I'm sorry, I have a flight to catch. So it's a
like
so for the cluster features, you can see that because we have 6 years of AI cluster, not just CPU cluster. We are very, very early team to collab with Jason Fang to develop an AI cluster. So you can see those features that we already have in ASUS. So please do not hesitate to ask us for your proposal for your customer. Thank you very much.
I think you have a flight to catch. Just go. I can take the rest. No worries.
Okay.
Thank you very much.
Okay, thank you very much.
Thank you. Doveva essere settato
Ah, ok, perché mi sembrava, siccome abbiamo cominciato allora di...
Avete cominciato?
Facciamo voi, scusate qua.
We are already time here? No. Okay, so we keep going in English. So let's pretend this is a start. My name is Daniele. I'm the Server Sales Director, and I'm here to introduce what ASUS is doing for the AI ecosystem. And as we are ASUS, we start from the hardware part, of course. And how many of you knew ASUS as a server provider, a server vendor before today? You can raise your hand, please. At least one of you raise your hand. Okay. We have a marketing part. We have basically everything that it takes on the GP, general purpose server part, but we are also very focused on the AI part. Our slogan is we are all in on AI, and if we look at the portfolio and everything that is on, everything but one, that is everything but two that are on this slide are available and in deployment today. If we start from the left side, we have short depth edge servers. Those are designed to deploy on premises on the edge. So we are talking about telco antennas, or even retail, or video surveillance and these kind of things. And those are pretty particular models because they can have front or back input outputs, and they can run on AC and DC power source. So eventually, we have a lot of customers using them, for instance, for broadcasting on bands. And although they are very small in size, they can host up to 3 GPUs, such as L4. So that is the first edge AI product range. We have then the inference part. This can be done on general purpose servers like RS720 or 720A. This is the Intel and the AMD version. The AMD version is the one with the A. And those exist now for Intel Xeon 4th and 5th and AMD Genoa solution. And in October we will launch the Turing version, and then of course the new Xeon 6 as well. Those servers can host up to the discrete GPU H100. Then we have, of course, the computing, and those run on Grace Hopper 200, and also on Grace Blackwell 200 MBL2, with the ESC and M1 and M2. And those are available currently now. We have the GPU series that can host up to H200 as a GPU inside, and everything that is below, of course, that. Up to 8 GPUs, and we are launching the Turing and the 6 series Xeon these days. And then, of course, we have the Gen AI series. So we have the NVIDIA HTX 200 that we are selling now. We are probably over the H100 stock. We might still have some, but the H200 is already in. So if you have needs for deployment, within 2024, we have stock available for delivery on H200 AGX. We are going to launch early Q1 next year, and this is one of the two products that are on the slide but not existing yet in real life, the MI 325 from AMD. And we are co-developing, we're developing together with Intel and ready to launch as soon as they will be ready for the Gallia 3. So basically there's nothing in our available portfolio or in the very earliest roadmap and original vendor availability that we are not going to provide to the market, which positions us, I think, in a good layer of top providers for airports. This is the part that Peter has already presented, so basically not only the hardware, but we understand it's very difficult also for existing and experienced data centers to run this kind of server. Don't forget that the latest, like the Grace Blackwell full rack that we can also deploy, this is going to weigh maybe 500-600 kilos, and we consume, they say 120 kilowatts, I think a little bit more than this. So you cannot fit it in any data center. The big problem is to power it, and also the pavement should be, make sure that it can hold this kind of weight. So we are available to help design starting from an empty room, all the infrastructure, the cooling part, the hardware, of course. This is what we mainly sell, service support, software, and the management. I'm going to skip the slides related to
if we can finish with, say, 5 minutes before 5, we will be more or less on time considering the delay. So,
when I touch the network things, this happens.
Me too.
So
I am proud owner of ASUS, if you want to know laptop, since it's
No, but it's my, I understand it's me, because I don't think that this can be personal on me. So what happened? Here, I don't see it. Okay, sorry, it doesn't matter. Okay, this, for instance, what Peter didn't mention because he didn't have time, is the first implementation that we did in 2018. And you can see here, this is a very typical cooling design. So you have hot and cold corridors. And then you have the direct-to-chip, the black here, cable that goes into the direct-to-chip for the CPU, and everything else is cool. You have a black, cold area and a hot area. And then,
try with the right button, yes.
And then on the new one, the one that we are delivering now, which is reaching 1.17, and I presented this slide to several data centers. They failed to trust this number. I think it's super impressive. That will run with an hybrid system, so you will have direct-to-chip, but with a rear door heat exchange. So this can also adapt to data centers that don't have pipes, that don't want to rebuild everything, especially when you install a full cool liquid. This thing is like 2.5 meter, the intercooler interchanger, and it's one piece. It's even very difficult to slide it into the data center. Something important that we mentioned that I would like to repeat is that our management system, so we provide the hardware, of course, we want you to manage, but we want you to be able to run your hardware pretty quick, configure, manage, exploit, make money. The more you make money, the happier we are, the more you can buy. And basically, if you didn't start doing business yesterday, you probably have a bunch of thousands of nodes that coexist before you happen to mix with an AGX solution. So our platform actually can use different GPUs and manage together as well. Different frameworks, different platforms. So you can have AMD, you can have Intel, you can have NVIDIA. Also for the CPU side, you can have Intel AMD and you can have ARM in the same, managed in the same cluster, like they were the same architecture. And then you can organize in different ways and allocate the resources of all the bunch of things you have here, you can organize in virtual machine container, parameter HPC, and then automatically either assign a quota or automatically manage the workload where you have free available resources allocated to those that are asking for it. Our platform is compatible with everything, so you can choose the kind of cooling, your network design, you're running on InfiniBand, you're running on Internet, it's fine. Your platform, your architecture, we already mentioned. File system, this is something very complicated, nobody wants to change their file system, everyone has a different organization and data files or whatever. We can manage whatever it is. And the governance we already mentioned. We already mentioned this part, so how does it work? Oh, beautiful, my notes are here. The generative AI solution has undergone plugin. Forget about it, thank you, Apple. So basically we have 3 layers. So we have application level, everything that you need once you have the hardware to use it. We have our own application, but you can use whatever application in the market, including your own. So our application is called Explain. This will help you run all your machine learning and language models. Foundry service decoder. This will help you code. So your own script, your own language, your own programming, what you are doing in your own company, you can code it with our application to Ethernet, or just put your application you prefer. Then you have the tool and platform, so whatever you need for the governance, for the cloud. And then you have the orchestration and infrastructure, so how you have split and how you want to manage. And then all of this can run on premises, so the servers are at your site, or on the cloud. It doesn't matter for our system. Something that we mentioned very quick, but I would like to mention again. Once you have your heterogeneous cluster of whatever hardware it is, and you put it together, then let's say you allocate, you have some language model training, inference, then you have some developers, and then you have some virtual machine. The system can automatically allocate GPU power, splits. Okay, so here you're doing some training on 2 nodes and inference on 1.5. The developers can use a little bit of this, a little bit of that. The system will simply allocate. And most importantly, above all, because we are here for innovation, for revolution, for the money, you can decide how to make the user pay for it. So imagine you're a research center or a data center lending out GPU power, or a university with different departments. You have chemistry, architecture, whatever. How do you assign the cost of it? Once you link with your price list, you can decide, okay, by duration, by volume, by subscription, by API calling, or by token, and at the end of the day, or whatever you want, have an exact clear picture of who used what and how much they have to pay for it. 8 weeks, starting from when the hardware is available, because sometimes it gets much longer just to get the hardware. But in 8 weeks, the standard implementation of the governance, the software and the platform can establish and run. So, let alone your customization of what is specifically your need, the whole system with licenses, virtual machine, etc., is going live in 8 weeks. Patent pendings and everything, and thank you. 2 seconds later.
No, it's perfect.
Thank you very much. Thank you.
Adesso
How you can...
Daniele la rifai anche in italiano, che ho capito poco.
Ma te la rifaccio dopo da
Dopo,
solo?
dopo. Vis-à-vis.
È lo stesso pezzo.
Questions? Domande?
Orders?
Orders? The most important thing.
Già dato.
Già dato.
I have some questions for Bob if you want. Not orders, but I'll try later. And so one question is that Taiwan, if I understand, is a grace system.
No, Taiwania 2 is a GPU, a multi-GPU system based mostly on PCI Express GPUs.
Okay.
2,000 and something nodes, I don't remember. Many nodes. 2,000 NVIDIA GPUs ranging from B100 to the A100 because that is 6 years ago.
Okay.
So AI didn't exist. Taiwania 3.4 are based on, especially 4 or 3 is based on AGX solution, and 4 is a grace.
Okay. So what the users say of being pushed to a transition to grace system? What are the communities that are impacted most? Because I guess that maybe somebody will say, oh, I am not ready to do this jump. My software is not ready, I don't know.
I think in terms of example, Taiwania is a HPC government project. So for them it's the overall compute capacity, consumption and everything. But in specifically for the end user or the business level, everyone is scared about, I don't know, for instance, I have NVIDIA architecture, how can I mix it with AMD or Intel coming out? Well, Intel has very specific usage that maybe cannot exactly compare one-to-one with what NVIDIA has done and AMD will introduce. But the truth is that even in current days to recompile CUDA, so an H100 workload based on NVIDIA CUDA libraries, recompile to an AMD MI200 GPU is for 90-95% of the overall result is automatic PyTorch kind of compiler that will just and make it available. So the user should not be. The thing is, we want to make this very easy to use. Otherwise, people cannot use it. That's why we have our own platform, and it's called no code. So you don't need to have. I'm personally now talking about things I don't understand, and we don't expect the user to understand them and to know what is behind it. The user can be a blonde driving a Ferrari, not supposed to know how the hydraulic system of the engine works.
Okay.
Just know how to drive it.
Okay.
That's the target. That's what we are offering, turnkey solutions.
Okay. Other questions? I have one for Jack also. If I remember that because this morning we heard a lot about shrinking power usage, and we saw this, I have to say, very beautiful number of PUE. But you mentioned several times, a couple of times in your talk, about the fact that you have 7 new ready solutions compared to 10. So is shrinking space comparably important to shrinking power usage in your opinion? And the other question is about the sidecar solution. There is some trade-off between, as I understand, it's easy to compare to a complete liquid transition, but what is the trade-off? Because there is not really much as far as I know.
So the first question will be, it really depends on how much power that you can offer in your rack, right? So we have customers that are ready for 100 kilowatt rack of the power drop in their data center. So meanwhile, they also want to tackle the biggest training large language model out there with the most efficient way. So they are looking at a system per rack. So they want to have 64 GPU in one rack. The only way that you can do that without going to the 32U high rack with the standard 48U rack should be 5-year system, or even less, right? And in order to do that, you have to do liquid cool, because if you buy HGX, it comes with the heatsink. It has before heights for 700 watts or 60 UI for the 1000 watts. You can get rid of that. So if you have 100 kilowatts of the power rack, you have enough liquid cooling infrastructure to handle this kind of power. That's the way you can go. However, we don't only do liquid cool. We understand that a lot of customers still have air cooling, environments. That's why we have different options for different customers for different use cases. Right. The second question is about the liquid to air. From PUE standpoint, the liquid to air definitely is not as good as liquid to liquids. That's for sure. Because one phase changing, you need to put this to the air, then air comes to the liquids and then going out to the data centers. It's purely for customers like, they have their traditional colo. They really want to tackle this kind of, high density GPU compute system, but they cannot afford to renovate their data centers. Or we have one very particular hyperscaler customers. They are really dedicated to the free air cooling. So they basically just put their data center in the Nordic countries. They just dissipate. They just dissipate the heat to the open environments. They don't care about those heats, right? So that will be ideal, but not everybody can handle that. So to your question, yes, liquid to air comes with a penalty on the PUE, but it gives you the freedom to without renovating your data centers for the liquid cooling system. Okay.
Other questions? So I don't know if you have some take-home message apart from not having Apple laptops and the speaker post. Just one comment while you think about the weight that you mentioned, the importance of taking into account the whole infrastructure. Sometimes in Italy we do have data centers in historical buildings that you can just modify as you want or build from scratch.
Some universities are now moving to the basement. But even basements, if you want to put 5, if you go liquid cooling, you can shrink the heatsink and have it 5 use, some even a little more, a little less, and then you can put 8 in a 44 cabinet rack, whatever. Then that's going to be how much in kilos. And then you have to power 150, 170, 180 kilowatt to that rack. And this is insane in a way, because what do you get? A single power source giving you 150 kilowatt, not even industrial cables, and so you will probably need to have 2 sources because one might fail. We have electrical failure at home, so it's no longer a matter of saying like the server has to be redundant. You need to have redundancy on the server, redundancy on the power source. So you need to get 300 kilowatt in a single rack. And the funny thing is that most of the data centers today, what they have done on CPU computing until now, the single rack is maybe 5% of this capacity, and they have no idea. And they are trying. Most of them are going to the north because the electricity compared to Europe is 0. And then they pretend they open the window and they can cool it, and then the Arctic cold and all the snow and the ice in the world will melt. So there is no super funny, easy solution that doesn't have a side effect. So we need to consider everything, and every single quarter, if not less, we have a launch of a new product, and that is promising on paper like 4, 5, 6 times the performance, like GB200 compared to H100 or H200. But that is actually more on paper because it's a particular usage on the specific topology on the given instruction set. But the real is that even the H100 that have been deployed in the last 2 years if they are running today, they are not being exploited for what they can do. So the next big stage, but now it's more of probably a fight on the supremacy, on the pure performance. The next stage is these things have to back down a lot in the consumption. Because otherwise, yes, it's very funny. I tried the other day to ask a ChatGPT a question in 4 languages. So I mixed my sentence and asked to reply in another language, and it did. I don't know who paid for the compute power of this stupid experiment, and I don't know who is going to be billed for that, and I also don't know the usage beside me showing my kid, draw me a dog with wings, and it does. So we need the last mile to the business, to the continuity, to the sustainability, and make sure it is the case. Okay.
So, if there are no other questions, thank you for being here. Thank you to our guests. Apologies for there was a bit of confusion, but we did our best, and see you.
Thank you.
Thank you.